Hi everyone, my name is Celso Montes. I'm doing the GIST Master's program at the University of Arizona, and my project's title is using ArcGIS dashboards to monitor scheduled Python geoprocessing scripts. Pima County is in the south end of the state of Arizona, and the seat of the county is Tucson. There's a little map on the right-hand side there. So some background on the project. So I created a method of keeping track of Python scripts and important metadata on the Python process and some developer information. And what was created was an ArcGIS dashboard to visually display that information. And currently there's no way to know how a Python job finished unless you are the owner of that Python job or have access to those servers or get emailed on the completion status of that job. It's going to make it easier for people to reach the GIS developer, and there's no Python required to understand the dashboard. A reference map was also created with dashboard elements to show recently edited features. So some of the methods, there's a module that I created called PC Monitor, Python module, and PC Monitor stands for Pima County Monitoring. And what it captures is the start time of the script, the name of the machine or server executing that script, the current working file directory of the script, the version of Python that is running, Python 2 or Python 3, and if a database connection is needed to write to the monitoring table. And if one is needed, it creates one, and any user inputs that are passed on as parameters. So for the developer, what's needed from them is for them to write one line of code at the very end of their script and to pass those parameters in that are not able to be obtained programmatically. A lot of the what you see in the dashboard was able to be obtained programmatically. So this is what that one line of code looks like at the end of a finally statement. It's the PC_monitor.environment settings function. The first thing that goes in is the task schedule name, the day of the week in a list format that the job runs, the time that the job runs in military time, first dot last name, whether or not the Python code is in the code repository, whether or not it's active or inactive, the input feature classes in a list as well, or the tables, and the output feature classes and table information. And then the last bit of code, it just grabs the .py file name. So for the dashboard end user, the dashboard viewer can gather a lot of information about these scripts, investigate the feature classes that are available in Pima County's metadata website. And it's highly interactive because you can select any of these feature classes and the metadata automatically populates on the embedded web page there. The end users can see recent edits in a map and the names of the GIS developers in Pima County. And the three feature classes that I chose were parcels, addresses, and streets, because those are the most edited feature classes in Pima County. And they are the most distributed and widely used. So here in this video, you can see that on the left-hand side, we have the list of all the Python jobs, the machine name. So that's the .py file name, the machine name, the folder directory where the job runs, then the inputs and outputs, the task scheduler name, and then the Python version, the start time and end time of the script, and the days of the week that it runs, and the next day that it's going to run, and next day and time. And then the status of the job, whether it's succeeded, finished with warnings, or failed. And if it finished with warning or failed, you'll get a status process message with the max severity information on there. You can email the developer, pre-populated subject line populates itself with the name of the script. And if while you have a script selected on that list of scripts, you can see the history of that job. So there you can see that it failed one time, the previous time, but then it succeeded this time. And here in the pie chart, you can select the blue or the yellow, and the blue is the color that I chose for successful scripts, and the yellow for finished with warnings. And the gray is for failures. Currently, there weren't any failures at this time, but later on in the test script, I'll show you how that works. And here on the right-hand side, you have a list of all the feature classes, and you can select the a feature class on that list, and the metadata for it populates in the embedded web page here on the left-hand side. So you can keep on selecting, and it's pretty user-friendly and highly interactive for the person. You can also select scripts based off server names or machine names, and up here you can filter through different various formats, such as see all of them, only the successful scripts, with warning. Here at the very bottom, you have new/modified parcels that have occurred in the last 24 hours, the addresses and the streets. And that the small number at the bottom is the number of new/modified features in the last 7 days. Here in this tab, we have a map. And what I did here was I created a map with those 3 feature classes, and using an arcade expression, I was able to classify the symbology using for the last 24 hours, 7 days, 30 days, and longer than 30 days. I'm going to show you in a little bit that arcade expression. It's a little small here, but it takes advantage of the last edited date of all the fields of all the feature classes. And all 3 of those feature classes have edited date fields in them. And it just returns the less than 24 hours, last 7 days, or 30 days. Next, I'm going to show you, and another thing to note is because it's I'm zoomed out at a small scale here, so there's a lot of features that have to load, and arcade expressions can take a while to load. Here I'm going to show you these addresses were recently added in the last 7 days, and you can see through the legend. And so you can see that this development now has new addresses. And that can be important because some people can be waiting for that information. And and I think that's the end of the video here. So I'm going to go on and show you how the script portion of this works. So in this video, there's a very simple script here. It just imports the ArcPy package and the PC monitor package. I have a couple other things in here, but they're not necessary for this script. Let me hit play. So here you can see the PC monitor, some local variables of a shapefile that's going to go into a file geodatabase, and a feature class to feature class conversion with the inputs of the shapefile, geodatabase, and feature class name. And at the very end, I have the finally statement with the scheduled name, the task schedule name, the days of the week that it runs, the time, the developer name, whether or not it's in the county repository or not, whether or not it's active or inactive, the inputs and the outputs. And here at the very end, it captures that .py file name. And so I'm going to run it, and we're going to see it show up on the dashboard here. So it takes a little bit of time to import those modules, but we can see here that it was able to copy, and we're going to go back and refresh the dashboard here. And right now you see that there's GDB live for Excella, and we're going to refresh, and we have the script monitor test.py, which was just run. It took about 3 seconds to run. So now what I'm going to do is I'm going to break the code. I'm going to break it so that we can see what a failure looks like. So I'm going to save that and rerun the job. And right away we get the failure. It cannot create the output because that file location of pima all underscore shp shapefile does not exist. I'm going to refresh the page, and now we have a failure. And so this is almost near real time that we get this information. Other than needing to refresh, we get that script failure notification right away. And we can see the history of that job and see that it succeeded all the other times, but failed this time. And there's the error. And I'm going to email myself because I'm wondering what's going on. And I want that data, so I want someone to rerun this job because I really want the data to get refreshed. So to conclude, Pima County now has this visual tool to see the status and information on geoprocessing Python scripts. And any developer with access to the PC Monitor module can add their script to the dashboard. And any user with access to the ArcGIS portal environment can view and access the dashboard. And so special thanks to Fernando for mentoring me. Jack Avis and Chloe for also mentoring me and giving me suggestions on the dashboard. Their input was very valuable to me in completing this project. Pima County, as well as the University of Arizona GIST program and the University of Costa Rica for letting me use this room that I'm in right now. Cool. Any questions?